When determining if a duct bank is required for conduits under a building slab, several factors come into play. Firstly, if there is more than one conduit running in parallel, a duct bank is typically required. Secondly, conduits that are larger than 4 inches in diameter often necessitate a duct bank. Thirdly, if the conduits are intended to carry hazardous materials, a duct bank provides an additional layer of safety and containment. Fourthly, occasions where conduits may be subject to physical damage, such as under driveways or parking lots, often require the protection afforded by a duct bank. The spacing between conduits significantly influences the need for a duct bank. If conduits are spaced more than 6 inches apart, a duct bank may not be required, provided other conditions don't necessitate it. However, when conduits are spaced less than 6 inches apart, a duct bank is generally required to ensure proper heat dissipation and prevent potential issues. Installing conduits directly on top of each other without any spacing is not permissible. This practice creates a significant fire hazard due to the lack of ventilation and potential for overheating. Additionally, it makes it extremely difficult, if not impossible, to pull wires through the conduits effectively. The minimum spacing between conduits is 6 inches to allow for adequate heat dissipation and ease of maintenance. Duct banks serve several important functions. Firstly, they provide physical protection for the conduits, shielding them from damage caused by soil movement, heavy loads, or accidental impact. Secondly, they improve heat dissipation by creating a uniform thermal environment around the conduits, preventing hotspots and extending the lifespan of the cables. Thirdly, they facilitate future maintenance and upgrades by providing a clear and organized pathway for cables, making it easier to add, remove, or replace conductors as needed. When designing and installing duct banks, it is essential to consider several factors, including the type of soil, the depth of burial, the ambient temperature, and the ampacity of the conductors. These factors will influence the size and type of conduits, the spacing between conduits, and the overall design of the duct bank. The National Electrical Code, or NEC, provides detailed requirements for the installation of underground conduits in duct banks. It is crucial to consult the relevant sections of the NEC to ensure compliance with all applicable regulations and standards. Some common types of conduits used in duct banks include rigid metal conduit, or RMC, intermediate metal conduit, or INC, and rigid polyvinyl chloride conduit, or PVC. Each type of conduit has its own advantages and disadvantages in terms of cost, durability, and ease of installation. RMC offers the highest level of physical protection, but is also the most expensive. PVC is lightweight and corrosion resistant, but may not be suitable for all applications. The selection of conduit type should be based on the specific requirements of the installation. The depth of burial for underground conduits is typically determined by local codes and regulations. However, the NEC provides minimum burial depths for various types of conduits and applications. The purpose of these minimum depths is to protect the conduits from damage caused by surface traffic, frost heave, and other environmental factors. It is essential to adhere to the specified burial depths to ensure the long-term reliability of the installation. The ampacity of conductors installed in underground conduits is affected by several factors, including the size and type of conductor, the number of conductors in the conduit, the ambient temperature, and the thermal conductivity of the surrounding soil. The NEC provides tables and formulas for calculating the ampacity of conductors under various conditions. It is crucial to properly direct the ampacity of conductors when installed in underground conduits to prevent overheating and potential fire hazards. When installing duct banks, it is important to ensure proper drainage to prevent water from accumulating inside the conduits. Water can damage cables and reduce their lifespan. Drainage can be accomplished by sloping the duct bank slightly and providing drainage openings at low points. It is also important to seal the ends of the conduits to prevent the entry of moisture and debris. Backfilling around duct banks should be done carefully to avoid damaging the conduits. The backfill material should be free of large rocks or debris that could puncture or crush the conduits. The backfill should be compacted in layers to provide uniform support for the conduits. Proper compaction will also help to improve the thermal conductivity of the soil, which can improve the ampacity of the conductors. After the duct bank is installed, it is important to perform a thorough inspection to ensure that all connections are tight, all conduits are properly supported, and all grounding requirements are met. Any deficiencies should be corrected immediately. Regular maintenance is also essential to ensure the long-term reliability of the duct bank. This may include periodic inspections, cleaning of drainage openings, and testing of the insulation resistance of the cables. By following these guidelines, you can ensure that your duct bank installation is safe, reliable, and compliant with all applicable codes and regulations. In summary, the decision to install a duct bank under a building slab is influenced by several factors, including the number of conduits, their size, the materials they carry, and the potential for damage. Spacing between conduits is a critical consideration, with a minimum of 6 inches typically required. Installing conduits directly on top of each other is strictly prohibited due to safety concerns. Proper design, installation, and maintenance are essential for ensuring the long-term performance and reliability of underground conduit systems. Always consult the NEC and local codes for specific requirements and regulations. When working with electrical systems, safety should always be the top priority. Always to energize circuits before working on them and follow all applicable safety procedures. If you are not qualified to work on electrical systems, hire a licensed electrician.